let V be the vector space of all real polynomials of degree less than equal to 3 together with the zero polynomial over field R, and let W1 be given to be as all those fx belonging to V such that f of 1 equal to 0, and W2 is given to be as all those fx belonging to V such that f dash 1 is equal to 0. And these are the subspaces of V. We need to find the basis and dimension of the sum of the subspaces, right? For that, first we need to find the generators for W1, and then we need to find the generators for W2, right? Okay, let's take a polynomial from W1 first, and let fx to be of the kind a plus bx plus cx square plus dx cube, and this belongs to W1. Because this polynomial is belonging to W1, what is the condition? That f1 should be equal to 0. So then f of 1 is, just put x equal to 1 over here, we get a plus b plus c plus d, right? And this is equal to 0. From here, let's get the value for a. So this is negative of sum of b, c and d. So therefore, if I rewrite fx the polynomial, just writing a to be as this. So this is negative of b plus c plus d plus bx plus cx square plus dx cube, right? Okay, let me take b common from these two terms. We get x minus 1, right? Similarly, let me take c common from the other term so that we get x square minus 1 and then dx cube minus 1. So what we notice that fx is a linear combination of x minus 1, x square minus 1 and x cube minus 1, right? But fx was arbitrary, right? So that means every polynomial belonging to W1 of the kind a plus bx plus cx square plus dx cube such that f of 1 equal to 0 is a linear combination of x minus 1, x square minus 1 and x cube minus 1, right? So let's write this. Fx is a linear combination of x minus 1, x square minus 1, x cube minus 1. But fx was arbitrary. So therefore, every polynomial of W1 is a linear combination of these three polynomials. So that means W1 is generated by these three polynomials, right? Okay, let's move on to the subspace W2 and let's find the generators for W2. Again, we need to suppose a polynomial that belongs to W2. So let me write fx to be of the kind a plus bx plus cx square plus dx cube. And this polynomial is belonging to W2. And what is the condition for that? For W2, if fx belongs to be such that f dash 1 is equal to 0, right? So since f dash 1 is equal to 0, okay, let's find out the derivative of fx first with respect to x. So it is b plus 2cx plus 3dx square, right? So f dash 1 becomes, if you put x equal to 1 over here, we get b plus 2c plus 3d. So this is b plus 2c plus 3d is equal to 0, right? So from here, let's get the value of b to be as negative of twice of c plus thrice of d. And if I write back the polynomial fx, so writing a as it is plus bx. So for that, I'm writing the value for b, that is negative of 2c plus 3dx plus cx square plus dx cube. Let me take c common from these two terms. So I get x square minus 2x. Similarly, if I take d common from the second and the last term, we get x cube minus 3x. So we are getting that fx is a linear combination of, let me write this a as a into 1. So fx is a linear combination of 1, x square minus 2x and x cube minus 3x, right? These three polynomials. But fx was arbitrary, so therefore every polynomial is a linear combination of these three polynomials. So thus W2 is generated by these three polynomials. Now since W1 is generated by these polynomials, W2 is generated by these 3 polynomials, then their sum is generated by all these 6 polynomials, right? Okay. To get the basis of sum of the subspaces, we need to get the coordinate vectors of all these polynomials relative to the standard basis, okay, because V is a set of real polynomials of degree less than equal to 3, so the standard ordered basis becomes x cube, x square, x1, right, having the number of elements 4. So to form the basis of sum of the subspaces, so to get the basis of sum of the subspaces, we need to write the coordinate vectors of all these polynomials relative to the standard ordered basis these, right? So the coordinate vectors for this first polynomial is, okay, what is the coefficient of x cube over here? It is 0. What is the coefficient of x square? It is 0. What is the coefficient of x? It is 1. And the constant -1 dash. So this is the first coordinate vector of x minus 1 that is relative to these bases, right? Similarly, let's write the coordinate vector for x square minus 1. What is the coefficient of x cube? It is 0. Coefficient of x square, it is 1. Coefficient of x, it is 0. And the constant, -1 dash. Dash means I need to write this vector in a column vector. So this 0, 1, 0, -1 dash means I'm writing this vector as like this in a column form, right? So similarly, let's get all the coordinate vectors for other polynomials also. So that is 1, 0, 0, -1 dash, and 0, 0, 0, 1 dash, 0, 1, -2, 0 dash, and then at last 1, 0, -3, 0 dash. So we are getting the 6 coordinate vectors relative to the standard ordered basis B, and let's write all these vectors in a matrix form, and then we need to get the echelon matrix form from that matrix. So I have already written these vectors in a matrix form. Just write these vectors in a row wise form. I'm having 0 in the first row for the first place, right? I'm also having 1 in the third row. So to get 1 in the first place, let me interchange the row 1 with the row 3. So my first operation is, so I am applying the first operation as I interchange the row 1 with row 3. So I am having 1 to be the leading entry for the first row. To make this to be as a leading element, I need to make this 1 to be as 0, right? For that, just multiply the row 1 with -1 and adding its elements to the row 6th. So the row 6th becomes 0, 0, -3 and 1, right? Okay. So I'm having all the elements to be 0 below this leading element. For the second row, the leading entry is 1. To make this to be as a leading element, I need to make this 1 to be 0. For that, I need to multiply the row 2 with -1 and adding its elements to the row 5th. So row 5th becomes 0, 0, -2 and 1, and writing the 6th row as it is. So now this 1 becomes the leading element for the second row. For the third row, I'm having the leading entry as 1. What is the leading entry? It is the first non-zero element present in the row. So here 1 is the leading entry for the third row. I need to make this to be a leading element. For that, I need to make all these 2 elements to be 0. For that, I need to multiply the row 3 with 2 and adding its elements to the row 5th, and also multiplying the row 3rd with 3 and adding its elements with the last row. So now this becomes the leading element for the third row. All other elements are 0, right? For the fourth row, I'm having the leading entry as 1. To make this to be a leading element, I need to make all these 3 to be 0 and also all these 2 to be 0. For that, I need to multiply the row 4th with 1 and adding its elements to the row 1. Similarly, multiplying the same row with 1 and adding its elements to the row 2 and also adding its elements to the row 3. So the first row becomes 1 0 0 0, second row becomes 0 1 0 0, and third row becomes 0 0 1 0. Please remember, these leading elements should not be disturbed while applying the operations, right? They should remain as it is. Writing the fourth row as it is, to get 0 in place of -1, multiplying the row 4th with 1 and adding its elements to the row 5th. And to get 0 in place of -2, we need to multiply the 4th row with 2 and adding its elements to the 6th row. So on applying the operations, we get 0 0 0 0 and 0 0 0 0 for the 5th and the 6th row. And now this also becomes the leading element for the 4th row. Okay, so we are getting this to be as our echelon matrix. And I'm having how many number of non-zero rows? These 4 rows, right? The non-zero rows. And now writing the basis for W1 plus W2 from these rows. Okay. This is the coefficient of x cube. This is the coefficient of x square. This is the coefficient of x, and this is your constant. So first element of the basis of some of the subspaces becomes as x cube only. Similarly, from the second row we get x square. Are you getting or not? See, for the first row I am having the coefficient of x cube to be 1 plus coefficient of x square is 0 plus coefficient of x is 0 plus there is also a constant that is 0. So the polynomial becomes x cube only, right? Similarly, for the second row we get x square because I am having the coefficient of x square to be 1 and other are zeros, right? And for the third row we get x, and for the last row we get 1, the constant polynomial, right? So therefore the basis becomes x cube, x square, x and 1. That are also the standard bases, right? So these are the bases for W1 plus W2, the sum of the subspaces, and the dimension of W1 plus W2 is equal to how many number of elements present in the bases? 4. So the dimension is 4. Okay, thank you.